In this tutorial, we're going to examine our first toolpath type in much greater detail. The toolpath type we're going to be looking at in this section of the course is the facing toolpath. To get started, we're going to need to create some geometry to work with, as well as set our Mastercam configuration file to imperial. So I've just opened a new file right before starting this recording, and the first thing I'm going to do is set my default units of measurement here to imperial. So I'm going to go to the File tab, come down to Configuration, and then at the bottom here, under my current default, I'm going to select inch. Again, your two options are inch or metric. Selecting inch, pressing OK, and then your scale at the bottom right corner should change over into inch mode. Now, we're just going to create a simple example here. We're going to go to the Machine tab first of all, and enable our mill, default mill. We have our few options here, auto-populate. We're going to go into our properties drop down, and we're going to go through tool settings and stock setup just briefly. Tool settings, again, we looked at this briefly, but we're going to do this a few times for emphasis and repetition. We're going to click on, under toolpath configuration, we're going to enable the first two options, assigning tool numbers sequentially and warning of duplicate tool numbers. Secondly, we're going to go to advanced options and enable all four checkboxes here. And then we're going to leave our material type as the default aluminum 2024, and we're going to leave feed calculation handled from tool. Over into the stock setup tab, we're going to set up a couple of things here. We're going to say that we're working with a block of aluminum that is 5 inches by 5 inches by 1 inch thick. So that all looks good. We're going to press OK. And upon doing so, you'll notice nothing is currently showing on our screen. Now, in order to show our stock on the screen, we're going to go back to stock setup here and enable the display checkbox right here, and then press OK. Now you'll see we do have our stock boundaries displaying on screen. If we do a dynamic rotation by clicking in our scroll wheel on our mouse, we can see that it is a 3D block, and this represents our material. I'm going to go back to my top view and create an actual object within these boundaries. With wireframe, I'm going to select a rectangle that is anchored to center and is the full size of my stock minus just a little bit. So I think what we're going to do is have our finished product be 4.75 by 4.75. Okay, now this allows us enough material left over on the edges to create a nice milled finish on all four sides. And then for the top of our part, we're actually going to lower, or rather we're going to raise our stock slightly above the zero, the Z0, so that we can face off a small amount on the top as well before we begin. Now, rather than just raising our stock, we're actually also going to increase our stock size slightly to 1.05 inches to allow for 50 thou on top of the material to face off. Now, currently, because our Z0 is set to 0, this additional stock would be put below the Z line, which isn't what we want. So we're going to actually set our Z0 to be that same amount, 50 thou, above the standard origin. This will make it so that that additional 50 thou we just added will actually be added to the top of the part, which we can more easily see from the front view. I will thicken my lines here so that it's a little easier to see across the axis line. But here you can see our rectangle from 2D sits here, and there's just 50 thou of blank material on top of that that can be milled off in order to create a smooth finish. So back to the top view, let's now look at our toolpath. We've done our initial steps here. Let's actually move forward. So we're going to go up to the Toolpaths tab at the far right of the ribbon here, and we're going to select the facing toolpath. Upon selecting face, it will bring up the chaining dialog box. By default, this will be for wireframe. As we are only working with wireframe, this would be our only option for chaining selection. However, a quick note about facing toolpaths. Facing toolpaths have a unique feature, which is that if I do not select any geometry at all, I won't get the normal error that would follow pressing OK with no geometry selected. With a facing toolpath, if you do not select geometry, it will assume that you want it to face the entire existing stock, which it bases off of that red stock boundary. This is exactly what we want in almost every case, so very often you won't be selecting any chains when doing a facing operation. Now let's step through these settings. A lot of these settings here are very similar between different toolpath types, so once we go through them once in detail, we can move through them a little quicker next time. The first screen here, Toolpath Type, allows you to select exactly that, the type of toolpath you wish to use. Now, it will only give you similar toolpaths to the one you selected, ones that can be easily switched between if desired. In our case, we did want facing, and facing is what's selected. Moving on to the next tab. From the Tool tab, we can select a number of settings. First and foremost, the tool that we want to use to cut this feature. We can select the Select Library Tool button right here, or by right-clicking in the white space and clicking Select Library Tool. You'll notice that Mastercam tries to auto-populate tools that it thinks you would want to consider for cutting this feature. In this case, it's guessed very well. It's realized that we are facing a part and therefore we probably want a face mill. So for this application, keeping in mind our stock is 5 inches square, probably a 3-inch face mill would suffice. A 3-inch face mill would be good because we can take our full pass of the material in just 2 cuts. Let's press OK. Now the 3-inch face mill is now here and selected. Now, being that we are working with aluminum, our feeds and speeds can be relatively higher than they would be for steel. But again, because we're not actually manufacturing this, we're not going to get too much into specifics in feeds and speeds in this course, as that is something that would tie into the machining side of this more so, and is really more involved with that aspect of this. So for right now, what we will say is we'll try to stick with some relatively conservative and round numbers for feeds and speeds that will work just fine for this and would be generally safe to run on most machines, if not all of them. So we are cutting aluminum, but like I said, we'll be conservative. So let's put in a spindle speed of 1500 RPM, and let's put in a feed rate of about, let's say 20 inches a minute should be fine. Yeah, let's go with that. Our plunge rate we'll also make sure is about 20 inches a minute. And then everything else here looks pretty good. We could probably even slow this down just a little bit to be a little bit on the extra safe side, but that should be fine. So 15 inches a minute, 1500 RPM. We're not too worried about the exact numbers here. Now, this would be something that's worth spending some time on, especially if you do pursue this in the machining field. It is a benefit to learn your feeds and speeds well, especially with the material you'll be working with. And this is an area where a lot of time can be saved overall in your program by selecting good choices in this area. So if you do have a background in machining or other manufacturing using machines, you're likely to already have a little bit of awareness as to what would be practical values to put here. For this course though, we'll just stick to some nominal numbers. Okay, so this is the tool screen. As we mentioned in a previous tutorial, this would be also where we could put comments if that would be useful. I'm going to just put a simple comment that says face the part. Again, keeping it brief and to the point, we want to put useful notes that identify different parts of the program but don't give unnecessary information. So this is a nice simple note that could help the operator if he's unsure what he's looking at. Cut parameters is our first screen where we have a number of settings we can play with here. First of all, we can choose our style of cut if we want to cut one direction or zigzag. I'm actually going to leave it on one direction, although it doesn't really matter in this case because of the size of our cutter compared to our work. We're going to take 2 cuts regardless, and this toggle over here, reverse the direction of the last pass, always makes it so that the second pass goes the opposite direction anyways. So whether we choose one way or zigzag, we'd get the same result in this case. Going down the list here, There's a few different things we can adjust here. I'm not going to go through every single setting, just so we just don't have the time. And in fairness, most of these settings we don't change very often. So for the most part, we'll hit on the things that are most commonly needed to be changed. Quick note here, this is a very important one, present on almost every type of toolpath, is the stock to leave setting. This allows you to intentionally leave behind material on a cut so that it can be finished later. Now in the case of our cut, we're only taking 50 thou, so by leaving 50 thou on the floors, this cut would actually do nothing. So we obviously want this to say 0 because we intentionally want to face off the top of the stock so that we have a flat surface to work with. We have some various overlap settings here for our passes. Generally these are pretty reasonable at their defaults. We can of course tweak these if we wish. Max step over as well affects how much the cutter can step over into the next cut. 75%, the percents are often shown on the left, and then the inch value or millimeter value, if you're dealing in metric, is displayed on the right. So for this one we can see it's saying that a 75% step over with a face mill would result in a 2 1/4 inch cut. Now we do know that our part is 5 inches across, which means if I leave it at 75% step over, it's actually going to take more than 2 cuts, because this 2 cuts at this step over would only be 4.5 inches. So if I wanted to take this entire part in only 2 cuts, I'd need to increase this step over value slightly, at least up to about probably 80, maybe 83%, 84%, something like that. Yeah, so we'll say like 85%. So if I did an 85% step over, which again, you do have to be mindful of these settings. We wouldn't want to take a step over that heavy if we were taking a very heavy cut, or if we were dealing with a much harder material like stainless steel or something. We're cutting aluminum and we're taking a very shallow cut of only 50 thou. So taking an 85% step over isn't really a big deal here. And we're also going to assume that we're cutting with carbide, so this is a fairly easy cut. So this would cut 2.55 inches per pass, and our part is 5 inches across, so this should guarantee that we can take our entire cut in 2 passes. This is a really good example of a toolpath optimization. If I had have left this at its default of 75%, we would have been taking a third cut that would only really have been cutting a few hundred thou, which is very wasteful and waste of tool movement. So this is a good example of how we can improve our tool times if we're paying attention. A lot of these other settings we don't really need to adjust too much. Again, you can see we do have an option here whether we want to climb or conventional mill, and as I mentioned in a previous tutorial, generally we always want to be climb milling, so we generally never change this. Depth cuts allows us to choose if we want to take multiple cuts of depth. Now in our case, again, we're only taking 50 thou, so unless we have a very weak machine, we shouldn't need to take that in more than 1 cut. So we'll leave this disabled. Linking parameters is a screen present in almost all, if not every, toolpath that I'm aware of. And this is where we adjust our actual cutting heights and safety heights. Something we generally always want to enable here is the clearance plane. Enabling clearance means that whenever the tool ends a cut, it will return to a clearance position before attempting to move again. This is very important so that we don't collide with other parts of the geometry, especially for dealing with a very complicated or a part that has many different levels to it. We wouldn't want to accidentally collide with another part of it when it returns to home. Generally, a 2-inch clearance is a little bit of overkill though. Again, this will depend on your part. For our purposes though, and for the way that I've programmed this part, keeping in mind my preference is generally to program in the negative z-axis. So any number I put in here, I know will be above the part regardless. Even if I only put 100 thou here, it's still always going to be 100 thou above the part. Now for safety and for not pushing limits right now, I'm just going to set this to 1 inch, which is plenty of space, at least in my opinion. 1 inch clearance above the part is more than enough for this application, especially considering we won't actually likely be machining this. A useful feature you can sometimes enable is the use clearance only at start and end of operation. This is helpful if you're taking a lot of cuts perhaps at a similar position where you're not worried about colliding with other geometry. You can enable this so that the tool isn't constantly returning to the safety plane, wasting time. Being that we're only taking 2 quick cuts, this shouldn't affect the toolpath all that much, but just for the sake of demonstration, we will enable this in this case. Now all of these different values, you can see them represented in this picture on the left. The retract height is the initial position that the tool will retract to between cuts for the same toolpath. The feed plane is where the tool transitions from a rapid move to a linear move. And the top of stock is where it currently expects the material to exist. The depth is where it plans to cut to. So currently, we know that the top of stock exists at 50 thou above the 0 mark. So that's why this says 50 thou. That is correct. Quick other note is these toggles on the far right. Our options here are absolute, incremental, or associative. Now, for any applications we're using, we will only be using absolute or incremental, and most of the time it will be absolute. So in my case, I actually want all of my values to be absolute for this toolpath. I want everything to be the absolute position I'm setting it to. I want my feed plane to be exactly 200 thou above the part. I want my retract rate, retract position to be exactly 250 thou above the part. Again, keep in mind it's beneficial to have the retract plane be above the feed plane for the reason I mentioned, that above the feed plane, Mastercam will allow the machine to rapid move. So retracting to 250 thou above the part will allow it to rapid to its next cut position rather than feeding there at a potentially slow speed. So that is a little note here about these two specifically and how they relate to each other. Top of stock, as I mentioned, is correct. The depth as well in this case is correct. So if we were actually running this on a physical machine, what we would want to do is we would want to cut our facing toolpath on the part. That would reduce our overall height of the part to the Z0 mark. Then we would want to touch off all of our other tooling in our CNC machine off that 0, if that was how we programmed the material, which, as I'm going to move through these tutorials, that will be how I'm programming it. So I will assume that the operator, well, I won't assume, I would intentionally tell the operator, or I myself would know, if I was machining this part, that I'm assuming that all of the tools will be touched off the Z0 position, and that only the first toolpath, the facing toolpath, and therefore the facing tool, is the only tool that would be touched off the rough surface at 50 thou above the part. So I would touch off, make my cut, and all my other tools would be set on that newly cut face. This would ensure accuracy of following cuts, as well as consistency throughout my program. This is pretty much one of the last menus we need to look at here. One other one we'll quickly touch on is the coolant tab. This will affect whether or not Mastercam will enable coolant by default through your machine. I'm going to assume the machine we're theoretically working with has a flood coolant method, so I'm going to turn on coolant flood, and that will be the last setting I will adjust for my face mill. I'm going to click OK. Now you will see, after adjusting that, we now have our toolpath being generated. Now I can go to view here and turn off my axes to see what's happening. Now you'll notice the first thing I'm seeing is that for some reason we are still getting 3 cuts on this part. Now I don't want 3 cuts, so let's see if we can sort out what's going on here. This is a really good example of troubleshooting a toolpath in Mastercam. I'm going to click on parameters, and we're going to go back to our cut parameters, which should be where this inconsistency is happening. So I'm seeing that our step over is correct, so that's good. Perhaps our problem is that by selecting one way, it's insisting on 2 cuts in one direction and 1 final cut in the opposite direction. So let's switch this to zigzag and see if that solves our problem. I'm going to say OK. Now you'll notice my toolpath has disappeared. The reason for that is that whenever you make a change to an already existing toolpath, similarly to when you make a change to an existing solid object, which we talked about in the last course, the toolpath will become dirty, or in other words, it will be broken. We have to regenerate the toolpath before it will work again. So I'm going to click this button right here, regenerate all dirty operations to see what we have. Now I'm seeing we're actually taking 4 cuts, which is absolutely not what I want. So let's go back to parameters again. Okay, so what's going wrong here? Well, taking a couple quick look here at things, I'm going to switch back to one-way cutting, and I'm going to adjust my across overlap to be 50% instead of 25%. Let's see how that adjusts things here. Okay, so it looks like we're spacing our toolpath out a little better. Let's increase this a little further. Sometimes the easiest way to solve a problem is just to trial and error a few settings until you get the desired result. So this across overlap, as I can see now, is actually affecting how far over the edge of the part we're cutting with each pass. So I actually don't need this to be as high as it is. However, by changing this value, I've learned what the problem is with our toolpath. The problem is that it's trying to overlap the edges of our part by 3/4 of an inch, and the max we're allowing our cutter to step over is 2.55 inches total, which means overall we're only cutting a total of 5 inches and 100 thou. 5 inches plus 0.75 extra is going to be 5.75, and we're only cutting 5.1 total. So this is where our inconsistency is coming from. It's trying to overlap the edges of the part for us, but that's actually causing us more harm than help. So let's increase our max step over to 90%, allowing us to have a little more clearance at 2.7 per cut. Now that puts our total up to 5.4 if my math is right, which means that if we can get this value to be less than 5.4 when added to our stock size, then this should cut in 2 passes. So I'm going to adjust this to be an across overlap of only, what would 20% be? That's 600 thou. So 600 thou plus 5 inches is 5.6, and we can accommodate up to 5.4. So this is still too high. Let's try an overlap of only 15%. Again, so this is 5.45, getting closer. Let's try a 12%. Okay, so a 12% edge overlap allows for us to have a 90% step over, and hopefully this should take our cut in 2 passes. So let's see if our math checks out. And of course it does not. So let's see now what else is happening. So our tweaking of that setting does make sense. I do believe that was the correct thing to do, but there must be another setting interfering. Okay, so I suspect what's happening is that this across overlap is based on each side. That's probably what's happened. So by saying 12%, that was setting the overlap to 360 thou, which while that is within our tolerance for one side, it won't be for 2 sides. So let's set this to 6%, which gives it a 180 thou per side, which still results in less than 5.4 overall, which is our tolerance limit. So let's check that. Now we have 2 cuts finally. So these are the kind of things that can be a little bit tedious to sort out, but knowing the things you can adjust to fix these problems is how you get a result that you're desiring. So in this case, we've potentially saved 50% of our cut time on this toolpath just by reducing the number of cuts by 1. Again, in a project like this where we're not physically machining this part, that may not be a huge deal, but if we were actually manufacturing this, perhaps even thousands of these, you imagine you've cut down 50% of your time on just one of the toolpaths. That could result in multiple hours, tens of hours, hundreds of hours of saved time down the road. So that even little tweaks like this are worth it. So this is a really good example of how we can optimize our toolpaths and really make the best use of the settings that are at our disposal.